Throughout the following video, I will be showing you how to solve the function x to the fifth minus 8x to the third plus 16x. So to solve this function, I need to find the domain, the range, the x and y intercepts, the intervals of increase, decrease, and constant, the relative extrema, which include the relative minimum or minimums, relative maximum or maximums, the end behavior and the symmetry, and then I also have a graph. But before I even plug this problem into my calculator, or this function into my calculator, there are three things I am able to find. I'm able to find the domain, the x and y intercepts. So to find the domain, I know that from Math 2, the domain of any polynomial will always be all real numbers. And I know this is a polynomial because I have three terms. The first term is x to the fifth, the second term is negative 8x to the third, and the third term is positive 16x. So that's why I have negative infinity to positive infinity. I can also write all real numbers as all real numbers, just write it out, or I can write it as an arc with two slashes through it. So the next thing we are going to be solving without our calculator will be the x-intercepts. So all you're doing for the x-intercepts is plugging 0 in for y, as I've done over here. I have 0 equals x to the fifth minus 8x to the third plus 16x. So I see there's the greatest common factor of x because there's an x in every term. So I took an x out, and that's why I have an x outside of the parenthesis. And inside of the parenthesis, I now have x to the fourth minus 8x squared plus 16. And I also need to make sure that I keep bringing that x down. From there, I see that I need to factor. And to factor, I need to multiply to 16 and add to negative 8. So I plugged in all the factors for 16 and realized that none of the positive ones worked. So I went to the negative ones, and I realized that negative 4 and negative 4 worked. So x to the fourth divided by 2 gives me an x squared in each parenthesis as well as a negative 4. After I did that, I saw that this is a difference of squares, which means that I can take the square root of each term that is inside the parenthesis, and I did that as you can see here. The square root of x squared gives you x, so I threw an x in this parenthesis, and the square root of negative 4 is going to be positive 2. But since it is a difference of squares, you also need the negative 2, as you can see. And I also need to make sure that I'm bringing down this x. So now we have x plus 2, and x minus 2, and now we need to put all three of those equal to 0 to give us our final x-intercepts. So x equals 0 is your first x-intercept, x equals negative 2 is your second x-intercept, and x equals positive 2 is your third x-intercept. So now we're going to solve for the y-intercepts. And solving for the y-intercepts is actually super simple because all you're doing is plugging in 0 for x. And since every term has an x, that basically is saying the y-intercept is going to be 0. So 0 to the fifth power gives you 0, 0 to the third power times negative 8 gives you 0, and 0 times 16 gives you 0. So that is all that we can find without the calculator. So now we are moving on to the things that we can plug into our calculator. So just to make it simple, I've already plugged in the function into my calculator and pressed graph, and this is what the graph looks like. So looking at the graph, I can tell what the range is. I can tell the range is negative infinity to positive infinity because this line right here is going on and on and on forever, and this line is going on and on and on. And because I have these lines going on and on and on forever in negative infinity and positive infinity directions, our domain or range will be negative infinity to positive infinity. So I just wrote it as negative infinity to positive infinity. But just like the range, it can be written as all real numbers. That works as well. So the next thing we're going to find are our intervals of increase, decrease, and constant. And one thing that we need to remember about our intervals is that every number that you write down will pertain to the x-axis. So first, we're going to find our intervals of increase. So by looking at the graph, I can tell that we have an interval of increase from negative infinity to positive 2 because this line is going up and up and up and up, and we know that this ends at infinity because there is no stopping point here. So I've written down like negative infinity to negative 2 as our first interval of increase. So our second interval of increase will be from here to here. And I'm not going to write negative 9 to positive 9, even though those are the y-intercept or y-coordinates. We're going to write the x-coordinates. So this is actually going to be negative 1 to positive 1. So, and we have that line right there. And I've written it down as negative 1 to positive 1. And our third and last interval of increase is going to be from positive 2 to positive infinity because it has an x-intercept or an x coordinate of 2, and it's going on and on and on forever. So our next thing we're going to find are our intervals of decrease, and for this one we only have 2. So our first interval of decrease is going to be from -2 to -1 because we have this line going down and the x coordinate changes from -2 to -1, and I have that written right there. Our second interval of decrease is going to be from +1 to +2 because once again we have this line going down and the x coordinate changes from 1 to 2. So our third interval that we need to find are our constant, and a constant is like a straight line, like the straight line I used here in my arrow, and as we can see by looking at our graph, we have none, so we're just going to write the word none. So now what we are going to do is we are going to find our relative extrema, which include our relative minimums and our relative maximums. So to find our minimums, all we're going to have to do is plug in second trace 3 on our calculators, and I've done that, and I did left bound and right bound, and it gave me a minimum of 2, 0. So I wrote 2, 0 right here, and for our second minimum, I'm going to do the same thing, second trace 3, and I'm going to come over here. And it gives me a minimum of -0.89 and -9.15. So what I did here is I just rounded to the nearest whole number. So my second minimum is going to be -1 and -9. Now for the relative maximums. We're going to do the same exact thing we did for the relative minimums, but instead of pressing second trace 3, we're going to press second trace 4. So I did that, and it gave me a maximum of -2, 0, and that's exactly what I have over here, -2, 0. So now for this relative maximum over here, second trace 4. And now we're going to go all the way up here. And we get a maximum of 0.9 and 9.15. So I did the same exact thing as I did for the minimums, and I rounded to the nearest whole number. So for the end behavior, we're going to look at the graph up close right here. And as we can see for this part, or this end of the graph, as x approaches -infinity, because this is the negative part of the x-axis, y is approaching -infinity because this is the negative part of the y-axis, and that's exactly what I have written here. And then for this end behavior, we have as x approaches +infinity, y approaches +infinity because this is the positive part of the x-axis and the positive part of the y-axis. Now for the symmetry, it's very easy to explain. So even symmetry is symmetry over the y-axis. So if I were to take the y-axis and pretend it was like the crease in a sheet of paper and fold it over, I would get symmetry over the y-axis, which is even symmetry. If I flipped the piece of paper of the origin, they would be right on top of each other, which is odd symmetry. In neither symmetry is just no symmetry at all. And in this problem, it is odd symmetry because if I were to flip the piece of paper of the origin, this would be right on top of this. Now we are looking at the graph. If you look at the graph, you'll see that I've labeled my 3 x-intercepts, my relative maximum here, my relative minimum here, my second relative minimum here, and my second relative maximum here. And I have lines coming from -infinity and going to +infinity. And I can check my work with my calculator, and I can see the graphs look fairly similar, but they're not going to look exactly alike because I'm not the best drawer in the world. But this is how you solve the function x to the 5th minus ax to the 3rd plus 16x.